Hi, my name is Natalie Howe. Today I will be discussing some interesting facts regarding my semester project. During my research, I had a lot of simple yet thought-provoking questions about the Dawn mission that I am excited to share in my presentation. In order to have a better idea of my past research and have a smooth transition into the facts I uncovered, I will briefly reiterate my introduction of my research paper. In 2014, NASA launched a long-term program to deepen this exploration. The goal was to send robotic spacecraft to examine magnetic fields, atmospheres, geological activity, and water presence on planets and asteroids. Between 2007 and 2018, 6 major missions were launched: Dawn, Kepler, the Solar Dynamics Observatory, Juno, Curiosity, and the Parker Solar Probe. Each mission played an important role in helping scientists better understand what makes planets habitable and how solar systems evolve. Among these missions, Dawn was especially important for what it revealed about the asteroid belt and the early formation of planets. Dawn provided critical clues about the building blocks of the solar system from its travel to Vesta and Ceres. This first chapter introduces NASA's broader exploration goals and sets the stage for understanding how these missions connect to one another, specifically through the Dawn missions. Why was the Dawn mission revolutionary? Well, prior to the Dawn mission, all spacecraft could only be capable of visiting one singular body per mission. Dawn was able to visit 2 bodies, the asteroid Vesta and dwarf planet Ceres, due to new tech. It was the first spacecraft in history to orbit 2 extraterrestrial bodies. These 2 are the largest objects in the asteroid belt between Mars and Jupiter. The usage of traditional fuel had its limitations as it was very heavy, but it burned out just as fast. To visit more than one body, the spacecraft would need to stop, start, and redirect. Only ion propulsion was capable of granting the team the ability to do that. From an outside perspective, the rocket system is the most necessary portion of the spacecraft build. It took 58 years for humankind to get off the Earth floor with the invention of the airplane, then to the first trip to space. Without the adequate research, no one would have ever been able to begin the exploration of space. The advancement of the rocket or booster to lift the spacecraft off the ground, launch it into space, and move has resulted in the switch or the new creation of traditional fuel being paired with the ion engine. The liquid propellant rockets consisted of liquid hydrogen with an oxidizer that when ignited creates a high pressure, high temperature exhaust for thrust. The solid propellant rockets are a mixture of fuel and oxidizer that is mixed into a solid block, for example, like fireworks. Once it ignites, the burn sustains until it goes, which equates to no throttle or ability to stop. The ion engine cannot launch the spacecraft off the Earth floor and into space. It's once the spacecraft has entered space that the engine can be turned on. The ion engine includes no fire or explosions, just electricity to ionize gas such as xenon by accelerating electric fields and injecting at a super high speed. It's a slow burn that when combined with the traditional propellant rockets, there are more opportunity for NASA as they don't have to rely on one singular mode of transportation. Before the Dawn mission, the emphasis on relying on the boosters had caused many issues, with missions sometimes proving to be fatal, such as the predecessor mission to Dawn and Deep Space One, which proved how dated chemical fuel was becoming and as to how beneficial robotic missions could be in the future. It also tested ion propulsion for the very first time. What is the reasoning for the Dawn mission's name? The mission was given its name as its goal was to study the dawn or the beginning of the solar system. The intentional missions to Vesta and Ceres, 2 of the oldest bodies in the asteroid belt, were seen to be the means of hope of uncovering the formation of planets. The Dawn spacecraft has traveled over 4 6.3 billion miles using ion propulsion and spent more than 51,000 hours thrusting through space. It took 95,000 images and collected over 167 gigabytes of scientific data. Dawn completed 3,000 orbits around Vesta and Ceres, the two largest objects in the asteroid belt, and reached as far as 367 miles away from Earth. Wow, isn't that something?
Alright, so let me walk you guys through what I think it's one of the coolest and, honestly underrated NASA missions, which is the Dawn mission. It launched back in 2007, and honestly, what it makes it stand out is that it was the first spacecraft ever to orbit two separate celestial bodies beyond the Earth, of course, and not just fly by them, but actually orbit them. It's a major feat in space engineering. The two targets were Vesta, a giant asteroid, and Ceres, a dwarf planet, both located in the main asteroid belt between Mars and Jupiter. These just aren't random rocks. They're protoplanets, meaning they're leftover building blocks from the formation of the solar system. Basically, studying them is like looking at fossils of, planets. And really what enabled this whole double orbit mission was ion propulsion. Most spacecraft use chemical propulsion. You burn fuel, you get a burst of acceleration, and then you coast. But Dawn was different. It used ionized xenon gas, which gave it a tiny push, but continuously over time. I would say it's like accelerating with a feather, but for months or even years. It adds up a lot. And, with the system, it only needed 425 kilograms, not tons, kilograms like xenon, to operate for more than a decade. That is insanely efficient. It's like driving across the country using a cup of gas. That's amazing. The spacecraft ran out of maneuvering fuel, like around late 2018, and that marked the end of the mission. But by then, it proved the point, that it had done something no other mission had. It mapped two worlds in deep space, up close, in incredible detail, and for a long time. And then now we go into my second slide, legacy and impact of Dawn. It carried the GRAND and the BIR for subsurface and mineral analysis. It discovered sign past water activity. It linked Earth meteorites to Vesta and became a model for multi-target missions. And of course, it was backed by NASA's policy and public interest. But I think we have to talk about what Dawn actually discovered and why I feel it matters a lot. And first of all, the tools on the board, they were no joke. It had instruments like the gamma ray and the neutron detector, or the GRAND, and also the visible and infrared spectrometer, or BIR. And these these weren't just fancy cameras. They were designed to look inside these worlds, not just snap photos. The GRAND helped detect chemical elements below the surface, like hydrogen, and it led to the discovery of past water activity. BIR was scanning for materials like hydrogen, hydrated carbonates, which also implied the presence of water, not just frozen or sitting in lakes, but locked into the rock itself. This kind of data reshape, how we think about these small bodies. We used to assume asteroids were, dry, just lifeless rocks, but Vesta and Ceres, they challenged in fact, some meteorites found on Earth were traced back to Vesta, which it's mind-blowing, meaning pieces of the asteroid came all the way here. That asteroid just randomly over there. That connects space geology with Earth geology, and it's an incredible thing to think about. And now beyond the science, the Dawn mission was also political and cultural success. It was funded under the NASA Authorization Act of 2010, which, if we remember, NASA was not doing the greatest back then. But this prioritized robotic missions, and it happened during a time of rising public excitement about space because, like SpaceX and all that. Shows, movies, astronauts were, like Peggy Whitson and Scott Kelly, all that helped, get public and political support, essentially, because we live in a we live in a country, where politics go first, and we have seen it very recently. So yeah, it's always amazing when to get political support as well as a group, not group as well as the countries. So the legacy is huge. It's just not a mission that did well. It became a blueprint. It showed that we can use one spacecraft to visit multiple worlds, collect high quality, long duration data, and again, the safest part, which is not having any human involvement. And that's really the future of planetary science, The goal is to make it flexible, efficient, and missions that unlock multiple answers at once, because again, these are pretty pricey, and if they fail, then we lose political support, and it's just bad. And yeah, that's exactly what Dawn did, and it's why it's remembered, as one of NASA's most successful robotic expeditions up to the modern, up to today, like 15 years later.
Hello everyone, my name is Katie, and today I'll be presenting Chapter 5 of the Dawn mission, specifically focusing on the conclusion of NASA's remarkable journey to the asteroid belt. So let's go ahead and dive into how the mission ended, why it mattered, and what it means for the future of space exploration. So for the mission end, the Dawn mission officially ended in November 2018 when the spacecraft ran out of hydrogen fuel. Without it, Dawn couldn't point its antenna toward Earth or adjust its position. And engineers tried to reestablish contact for several days, but when those efforts failed, they confirmed that the mission had ended. So for the slide graveyard orbit, although the spacecraft stopped functioning, it wasn't left drifting. Engineers ensured Dawn would remain in a stable orbit around Ceres, which was a dwarf planet in the asteroid belt. This, quote, graveyard orbit keeps the spacecraft from crashing into Ceres and contaminating its surface, respecting NASA's planetary protection guidelines overall. For the final content and NASA announcement, after concluding that Dawn could no longer be reached, the Jet Propulsion Laboratory project manager had recommended ending contact efforts. NASA then made an official announcement to the public. This had brought closure to a mission that had lasted over a decade, providing groundbreaking data from two worlds, which was Vesta and Ceres. So the real impact of Dawn lies in the scientific legacy it left behind. It helped us better understand how planets form and evolve. Its findings at Vesta and Ceres, including possible water-bearing materials, have laid the foundation for future missions. Dawn then showed that even small celestial bodies can teach us big lessons about our solar system overall. So for the science team and collaboration, the mission success was due in large part to its dedicated science team, experts from across the world working together. Although the spacecraft is silent, the data it had sent back continues to be analyzed. Its influence on space science and future missions is far from over. So the final closing, in closing, the Dawn mission may have ended, but its contributions to science continue. It's a powerful reminder of what robotic missions can achieve and how even after they go silent, they still speak to us through the data they leave behind. The ending of the Dawn mission marked not just the conclusion of a spacecraft's journey, but the beginning of a new era in a planetary science. Successfully orbiting and studying both Vesta and Ceres, which were two extremely important part of the Dawn's mission, also because they were both the largest objects in the asteroid belt. Dawn became the first mission to visit two bodies with one spacecraft, and its carefully planned and in a stable orbit ensures its legacy continues without harming future scientific investigations of Ceres. While Dawn may no longer transmit data, the wealth of information it gathered will guide researchers for decades to come. The mission serves as a powerful example of how robotic exploration can yield long-term scientific value far beyond its operational lifespan, and would hope to continue to motivate scientists and researchers to continue on what they couldn't with Dawn's mission, and hopefully to find more, especially the things that they found with Vesta and Ceres overall.